Okay guys, so today we're going to be looking at 13.2, which is just some more factoring and reviewing trig. So today what we're going to be working on in terms of factoring is the substitution method. So we use substitution method for factoring when we see quantities that we want to use to factor, but they're kind of throwing us off in terms of what method or how we can use them to factor. So remember, we called that a substitution, where we would let a equal something. So let's look at example 1. In example 1, I have a plus c squared plus 5 times a plus c minus 14. Normally, when we were factoring with substitution, we would let a equal our quantity, but because a is inside the quantity that I'm already looking for, let's choose a different variable. So I'm going to say let w equal a plus c, and then let's substitute w in for everywhere that we see a plus c. So that's going to be w squared plus 5w minus 14. Now this looks a lot easier and nicer for us to factor. So we can factor this using the diamond method. The two numbers that multiply to negative 14 and add up to positive 5 are positive 7 and negative 2. So let's factor that. So that's w plus 7 times w minus 2. And then the last thing we have to do is we need to substitute a plus c back in for w, because w was not part of our original problem. So we plug in a plus c plus 7 times a plus c minus 2. That's as far as we can go, so we are done factoring. Example 2, we have x squared plus 10 or minus 10x plus 21 squared minus 2 times x squared minus 10x plus 21 minus 15. So let's, I'm going to use w again because that was easy. So let's let w equal x squared minus 10x plus 21 and substitute it in. So that's going to be w squared minus 2w minus 15, and we're going to use diamond method on that. The two numbers that multiply to negative 15 and add up to negative 2 are going to be negative 5 and positive 3. So that's going to be w minus 5 times w plus 3. So when we substitute our original quantity back in, that's going to be x squared minus 10x plus 21 minus 5 times x squared minus 10x plus 21 plus 3. We need to combine like terms as much as we can, so let's do our addition here. So that's going to be x squared minus 10x plus 16 times x squared minus 10x plus 24. Now, I would take a look at all of this, and if you guys have noticed, what we have can also be factored. So we're actually going to factor it one more time. The two numbers that multiply to 16 and add up to negative 10 are negative 8 and negative 2. So that first quantity can be factored to x minus 8 times x minus 2. And our second quantity, two numbers that multiply to positive 24 and add up to negative 10, are negative 4 and negative 6. So our entire thing factors to x minus 8 times x minus 2 times x minus 4 times x minus 6. And that would be factored all of the way. Okay, our last one, example 3, is 25 times x plus y squared minus 36x squared y squared. So we have two options here. We can rewrite this using substitution, or we can just ignore the substitution and rewrite our term as 5 times x plus y and then the whole thing squared. So this is actually the base that we're squaring minus this guy would be 6xy squared. And we can do difference of two squares from there. So let's set up our difference of two squares. We take the square root of the first one, which is already laid out for us. So that's going to be 5 times x plus y plus 6xy times, and then we'll do the same thing again, 5 times x plus y minus 6xy. So what we did here was we took the square root of each one first, so then we could just plug them into our difference of two squares rule. So to simplify, distribute the 5. So that's going to be 5x plus 5y plus 6xy times 5x plus 5y minus 6xy. There are no like terms to combine, so you are done. So let's take a look at one trig review problem, and then we will be finished. So for our last example, example 4 with trig review, here's the triangle that we're going to be working with. So we have triangle ABC. Angle C is your right angle. AC has a length of 4 and BC has a length of 8. So obviously this is not to scale, but just mark it what we have. And this is the triangle that we're going to be using to find our trig review. So just draw out the triangle first. So our problem is asking us to find the sine, the cosine, and the tangent of this triangle for angle A. However, I am missing the hypotenuse, and that's going to be important for each one of these because the hypotenuse is part of sine and cosine. So to find the hypotenuse, we're going to use Pythagorean theorem. So let's write that down. Remember, the Pythagorean theorem says that a squared plus b squared equals c squared, and your hypotenuse is the c. So let's plug in what we know to solve for c. So a squared is going to be, let's use 8, so that's 8 squared plus b squared, let's use 4, equals c squared. So 8 squared is going to give me 64, plus 4 squared, which is 16, equals c squared. 64 plus 16 is 80, which equals c squared. So to get c by itself, we take the square root of both sides. So we have that c equals the square root of 80. Let's see if we can break that down at all. 80 breaks down to 5 times 16. 16 breaks down to 4 and 4. So we can pull out the 4's. So root 80 is the same as 4 root 5. So let's write that in our triangle. So our hypotenuse is 4 square root 5. So your triangle is labeled, so now let's use that to solve for sine, cosine, and tangent of angle A. So we're looking at angle A is what we're looking for. So the sine is equal to opposite over hypotenuse. Using SOHCAHTOA. So of angle A, the leg that is opposite of angle A is 8. So we're going to plug in 8. So that's going to be 8 over hypotenuse, which is 4 root 5. Let's reduce the 4 and the 8. 4 goes into 8 twice, so that's going to be 2 root 5. However, I don't like root 5 in my denominator, so let's rationalize by multiplying by root 5. 2 times root 5 gives me 2 root 5. Root 5 times root 5 gives me 5. So the sine of angle A is 2 root 5 over 5. Cosine, using SOHCAHTOA, is adjacent over hypotenuse. The leg that's adjacent to angle A is 4. So that's going to be 4 over 4 root 5. Reduce the 4's, so we get 1 over the square root of 5. Same thing, we can't have root 5 in the denominator, so rationalize. And that gives me root 5 over 5. So the cosine of angle A is root 5 over 5. And then lastly, the tangent of A is opposite over adjacent. So since we're looking at angle A, the opposite is going to be 8. The adjacent leg is 4. So it's going to be equal to 8 over 4, which reduces to 2. So the tangent of A is going to be 2. That is your factoring and trig review for today, so you guys can work on your homework for the rest of the period.